Okay, this is some help on number 5 of the quiz problems. So you've got these two cars, car A and car B, and they're traveling along, and you're trying to find different things. For example, the first one wants to know what time are they traveling at the same velocity. So since this is a velocity time graph, the values over here are your velocities in meters per second, and then down here is your time in seconds. So you're looking for information on that. So in part A, you're basically looking for this point where they cross. You use that to figure out your time, figure out your velocities. You're good. The other question, part B, wants you to find accelerations. So acceleration is a change in velocity over your change in time. Or in other words, it's the slope of these lines. So when you try to find out that information, you should be able to find the slope of each line. A has a nice gradual slope. It'll be a nice positive number. B actually, it doesn't have a slope, so you can take that and work it. The next one is the displacement. So displacement is going to be 1/2 your initial velocity plus your final velocity multiplied by your time interval. So I want you to find the displacement for the entire length of time. So from here to here, so this was 0 and this was your final time. So you're using that by figuring out what the initial velocities are and the final velocities are. So you can kind of plug those in. So you should be able to find a displacement for A and displacement for B. Now displacement for B is going to be a little bit easier because it doesn't actually change velocity. So VI and VF are the same. So taking half of it is not really necessary. It's really just going to be the velocity of B multiplied by time. Now for part D, here's what's going on is you're trying to figure out at what time will they both have traveled the same displacement. So in other words, we want the displacement of A to equal the displacement of B. Now, this seems like a good equation for using for A. However, that was for the entire time, and I don't actually know the time, and I don't know what the final velocity would be. That would I'd have to figure out where is when they're actually traveled the same displacement, where are they? So a different equation I'm going to suggest is actually to use the fact that it's the initial velocity times time plus the 1/2 the acceleration multiplied by time squared, because you have the acceleration up here that you found in part B, and then you set it equal to this. This time you can just use this because it's going to be V, the velocity of B, multiplied by time. Now the initial velocity of A is 0, so this part's going to cancel out. So you just have this part. Also, you have a time over here that can cancel out one of the times there. So what you're trying to do is solve for the time. So you're going to plug in the acceleration that you found in part B right here. You're going to plug in the velocity that you can see off of this graph right here and solve for time. So in essence, time is going to be 2 times the velocity of B divided by the acceleration of A. Hope that helped on this problem number 5.